Welcome back. This is the day Lord's made. Let's rejoice, be glad in it. I want to spend a few minutes talking about how to solve a titrations questions from Unit 5 in chemistry. So this is a B-level titrations question. So a sample question you might see is, how many milliliters of a 1 molar phosphoric acid, that's H3PO4, are needed to neutralize 30 milliliters of 2 molar cesium hydroxide? So again, background for this is a titration is just a way to figure out how much of something do you have. So how much of this chemical do we actually have there? So going back to balancing an equation, phosphoric acid, H3PO4, will react with CSOH to make water and cesium phosphate. Again, acids and bases like each other. It's not balanced yet. We can balance it by just connecting the hydrogens to the OHs. So there's 3 hydrogens here, 1 OH, so we need to have 3 OHs so that every hydrogen has an OH, because every acid plus a base makes a water. And again, the acid or base here is how many hydrogens are being lost, how many hydroxides are taking the hydrogen. So the backstory again is, if you want to know how much of the phosphoric acid we need to have to neutralize it, we need to know how much of the base we have to start. And so again, an old equation is molarity times volume is equal to moles. And so we can find out how many moles of this we have, the cesium hydroxide, and then we can find out how many moles of this one we need. So molarity times volume is equal to moles. So if you have a 2 molar cesium hydroxide solution, I've converted the volume here to liters. So that's going to be 30 milliliters is 0.03 liters. We have 0.06 moles of cesium hydroxide. And going back to our stoichiometry, if we have 0.06 moles of cesium hydroxide, and the balance equation calls for 3, and this recipe calls for 1, we can cross multiply 0.06 divided by 3 equals x over 1, where x would be how many moles of the phosphoric acid we need. Cross multiply, we get 0.02 moles of acid. Now go back to find the volume. Knowing we need to have 0.02 moles of acid, and we have molarity. Moles over molarity is going to be our volume. So 0.02 moles divided by 1 molar, 20 milliliters. And this is the slow way, but this is the understanding. Again, the question is, how much do we need to neutralize it? The whole process is find out how many moles we need using the balanced equation. Then we can come back through and find the volume. The fast way to do it is to use this fancy equation. Molarity of the acid times volume of the acid equals molarity of the base times the volume of the base. You'll see this is really just moles anyway, because molarity times volume is moles. So we're saying how many moles of the acid do we need to equal how many moles of the base we have. So again, our original question, how many milliliters do we need? We can just use this equation here. Now, we will have to make some modifications. This 1 molar phosphoric acid solution is not just 1 molar when it comes to hydrogen, because it actually produces 3 hydrogens. And so when we use this equation, we just take the concentration given to us and multiply by how many hydrogens it has. Since we have 3 hydrogens there, we take 1 times 3, and that actually acts like a 3 molar solution of hydrogen. This one only has 1 OH, so we leave it just as that concentration there. So you'll see we'll get the same answer by just taking 1 times 3 times some volume equals 2 times 30 equals 60. So again, fast way to solve a titrations question is to use this equation here. Molarity times volume equals molarity times volume for the acid and the base. Take note of how many hydrogens you have, multiply by the molarity of the acid. Take note of how many OHs you have, multiply by the molarity of the base.